The first is going to be angle concepts related to parallel lines. So if you recall that, if you have these two parallel lines with angles 1, 2, 3, 4, 5, 6, 7, 8, all of these angle relationships. Remember, we have corresponding angles are equal, so that would be something like angle 1 and angle 5 here would be corresponding angles. We have alternate interior angles being equal. That would be an example like angles 3 and 5. We have alternate exterior angles are equal, so that would be like saying angle 1 is congruent to the alternate exterior, which is angle 7. And then we have the consecutive interior angles or same side interior angles. Okay, SSI or CIA means the same thing, and that would be a case where you're looking at angle 4 and angle 5. And the relationship for the consecutive interior angles or the same side interior angles is that they are supplementary. So it's going to add up to 180. And so these would be the concept reviewed for parallel lines and angles. Okay, the additional angle concepts are what we just looked at. Okay, so you would need to know that in a circle, the central angle corresponds to the arc measure. Okay, from the chapter with triangles, okay, which would be sort of the heavily used concepts on the SAT, you need to know triangle sum. Just a quick reminder, if you have triangle ABC, that the measure of all of those add up to 180 degrees. You also have the relationship of a 45, 45, 90, and 30, 60, 90 triangles. Okay, so this is a 45, 45, 90 triangle, isosceles right triangle, okay, meaning that these are 45-degree angles. And the pattern for this is x, x, x root 2. Okay, I don't have it written down here, but I am going to put it in this same set, which is 30, 60, 90. And in a 30, 60, 90 triangle, you have x that is the length of the side opposite 30 degrees, 2x is the hypotenuse, and x root 3 is the side opposite the 60 degrees. Okay, in addition, we have similar triangles as something that you need to be aware of. So if you have triangle ABC similar to triangle DEF, then you know the following. All of their corresponding angles are equal. And you have all of their corresponding sides are proportional, right? So we talked about this recently. AB over the corresponding side DE, that's the same ratio for all parts. So BC over EF, and also CA over FD. Okay, so those are all of the equal relationship or equal ratios. Okay, circling back to our continuing with the triangle concepts that you need to be familiar with. Pythagorean theorem, again, holds true for right triangles. A squared plus b squared is equal to c squared. The sum of the squares of the two legs is equal to the square of the hypotenuse. And then finally, the last triangle concept to be aware of, and often this is going to be tied together with similar triangles, and that is just the basic trig ratios. Also true for right triangles. So here we're looking at angle A opposite side, or angle A opposite side lowercase a, and so on. And this is based on SOHCAHTOA. Where sine of A is equal to opposite A over hypotenuse, cosine of A is equal to adjacent to A, which is side B over hypotenuse, and tangent of A is equal to the opposite over adjacent. And so that would give you your ratios. The final concept, once again here, for what you're going to see in this set is just the area and perimeter concepts, mostly rectangles and squares, potentially a triangle, potentially a circle as well, but for the most part, they are heavily rectangles where you have a base and a height. So the area is base times height, and the perimeter is 2 times the base plus 2 times the height. And for a square, you just have one side length s, so the area is s squared, and the perimeter is 4 times that same side length. Okay, and so these would be the relationships that you're looking at for your geometry review.